On the Fisher preamplifier equalizer, what I'm doing here is I have an auxiliary power supply that can pump some voltage into the main filter capacitors, and if it goes in through the selenium and then through the diodes, through the network, it can give a little bit of energy on each of the capacitors. What I did though is I pulled the tube out. So without the plate being in the circuit, of course without any filament being in the circuit it shouldn't matter, but I pulled the tube anyway. I'm going to just bring the voltage up slowly. And monitoring current over here, the current comes up a little. The meter over here isn't showing it as well. Bringing the voltage up and get it up to about 100. It's 150 volt capacitors. Got it at 116. I'll just flip the switch off and watch it wind down, and it doesn't hold very long, but there may be something in the circuit also draining it down. I can take the wire and short it out, and it goes to 0, which I'm sure my hand blotted it right out. Go ahead and hook that wire there, and I can do that over here anytime I feel like it. Okay, I'm going to bring it back up. It's up to 117. Bring it up to about 140 something. That's near 150 volts. Turn it off. Discharge it. Not much of a spark there. I almost would expect a little more spark than that. But it's an old capacitor. Bring it back up. And now I'm just going to back it down to 120, 100. And I'm going to go ahead and stop here and just let it sit and soak up a little energy for a while. The Fisher preamplifier equalizer has been holding voltage for quite a while now. So I'm just going to turn it off. Discharge it. And remove all the wires. Now I'm going to plug the tube back in. I notice that there's a ground wire. The tube socket floats, and the ground wire to the tube socket, it's a braid up inside, and it is broken. So that could be injecting some hum into it. We'll take care of that in a little bit. I want to fire it up and see what it does. So I am going to, I have a light bulb, and I have an on-off switch, which is off. I'm going to set the light bulb there, and I'm going to plug it in. With the switch off, plug it in, and the light bulb has done nothing. Since the light bulb is over here, I'm going to move the camera over here. And I'm going to turn the switch on. And there's no action at all on the light bulb. So leaving the light bulb in the circuit, I'm going to come back around. Just take some voltage measurements. Connect the ground leg to the chassis. And probe around here. Volts 200. Right off the selenium rectifier. 0. Back to the Fisher preamplifier equalizer. I shorted out the leads. The light bulb is functioning, so I couldn't get into here to check it to see if I had AC volts coming in, and I still can't get into it without removing the wiring nut. I know that I do have AC coming in. It's just a matter of trying to poke around here. Let's look at the transformer secondary. And on the transformer secondary, I do see 126 volts. No way in the world can I seem to get this to line up. 127 volts AC coming in. So that's with the light bulb in the circuit. Okay, turn it back on. Go over to DC. 200 volts. A minute ago it didn't work. So let's see if it's going to work now. We know we have AC coming out of the transformer. And there we have 152 volts. I'm telling you, a minute ago it didn't work. But it decided to start working. So we have 152 volts there. 96 volts on the second capacitor. And 60.9 on the final capacitor, or 61. So we have voltage going into the tube. And let's feel the tube. The tube has some heat to it, so it's not like I can look at it and see the filament lighting. But the true green leads are going to put AC volts on the filament. And I have 6.4 volts showing on the meter. So we had the initial fire up. It wasn't easy, never is, especially when you're trying to make a video doing it. Okay, back on the Fisher preamplifier equalizer using the 6SC7 tube. I'm going to go ahead and connect it before I go doing any component checks, just to see what it works. I hate to change things and see how it might have worked to start with. What I'm going to do is I'm going to run a phonograph. I'm going to run the left channel only because it's a mono unit. And right now I have it going through a solid state preamplifier. And there's another amplifier in the background over there that we're playing through. So that if I just drop the needle on the record, the scope was monitoring, of course, the left channel. Couldn't possibly monitor the right channel, since that's the channel I chose to use. Okay, now we know that works. I'm going to just pop this up a little bit and go over and make the connections to the preamplifier. Inputs over here, outputs there. What's the chances of the lead reaching to the input? It does. And the output lead here. There's the on-off switch. And I'm ready to plug it in. I'm going to go ahead and put the needle back and drop it on the record. And I'm going to plug the amplifier in. Wouldn't come on, and the reason it wouldn't come on is the switch in the back is not functioning correctly. Take the meter, and I can measure the switch now, and I can measure the DC. We're going to get this right. I hear it humming, so it's actually on. It's 161.2 coming right out of the selenium rectifier. I'm going to drop the arm on the record and of course it's working. Now there's a lot of buzz and rumble. Let's connect ground of this. I'm going to put the ground to the record changer ground. that goes away completely. All the humming and buzzing. But I am going to play a test record on there. And the test record coming down. And I got to cue it. I hear a lot more noise in it than shows on the scope. But anyhow, the amplifier is working. So we'll put that into some of these. We have the different settings. And we'll hold it here. Just want to get a few voltage checks while I have it set up here like this. Considering you consider that the paper caps are going to be bad because it's an old unit, just like I considered that the selenium rectifier would be bad. But the output of the selenium rectifier I have 162 volts. So I'm just going to make 162. I'm going to write it down for the output. Over to this would be the first cap. At the second cap, it's 133. And at the third cap, which would be the output, I have 109, 108.4. We'll call it 108. Okay, at the grid, coming in on pin 3, which broke, by the way, I'm just going to take a reading and come up with 0.4. 0.4 on pin 3. Let's see, that was 0.04, isn't that right? 0.4. Okay. Then I'm going to go over to pin 2, which should be the plate of the first of the triodes. And the tube's pretty warm now. So pin 2 is here. 65.4. And then going up to pin number 4, which would be the grid of the next stage. And 0.2, 0.2. So if the capacitor is leaking electrically, I don't see it. Pin 6 would be grid for both triodes, and that's ground potential, so that should be 0. Pin 5 would be the plate coming out for the final stage. So I just can't hardly see in here. But and we know there's voltage there. Let's see, the grid coming in is pin number 3. So 4 and 5. I'm not reading anything. .2. 61.2. And going into the network, so to see if there's any voltage coming out of the network. No. So it really looks like the thing is functioning pretty good right now. So until I decide about any further tests, I pretty much have it functioning somewhat. I hate to change capacitors that don't need to be changed. Just unplugged it, let it go out cool. Still got 42 volts coming out of the thing. Okay, that'll stop for now.